Hey everyone and welcome back to Experts Academy. In today's video, we continue with LPIC 1.101.3 module focusing on run levels and targets. In the first part, we dove into the world of run levels and now it's time to explore SystemD targets. If you have been following along, you know we've already covered init systems in previous videos. Now SystemD is next step forward, replacing the older init systems like sysvinit or system5init. And just like SystemD has taken over from traditional init, SystemD targets are the modern replacement for run levels in Linux. But instead of just numbers, they offer a more flexible and powerful way to manage how your system starts up and shuts down. Let's dive in and see how they work. Just like old run levels, SystemD has its own modes that your system can run in, and these are called targets. But unlike run levels, targets are a collection of services grouped together to reach a specific system state. In our last video, we talked about traditional sysvinit run levels, which were used to define different operating states for Linux systems. We had run level 0, which was halt, run level 1, which was single user mode, run level 3, multi-user mode without a graphical interface, run level 5, multi-user mode with a graphical interface, and run level 6, which was reboot. Now with SystemD, these run levels are replaced by targets, which offer way more flexibility and control. Instead of just saying multi-user mode, SystemD lets you get more specific, like whether you want that mode with or without graphical support or adding in other services. It also manages dependencies between services, so everything runs. Let's take a look at some of the most commonly used SystemD targets and how they relate to the old run levels. Default target. The target your system boots into by default, usually linked to either graphical target or multi-user target without a GUI. Graphical target, just like run level 5, this sets up a system with a graphical interface. Multi-user target, similar to run level 3, it sets up the system without a graphical interface, but it still allows multiple users. Rescue target, comparable to run level 1, starting the system in single user mode for rescue and maintenance. Emergency target provides a very minimal environment for emergency maintenance, even more limited than rescue target. Halt target stops and halts the system. Reboot target reboots the system, and power off target, which powers off the system. Now, if you remember from 101.2 module, we talked about the systemctl command. Just as a quick reminder, systemctl is used to control the SystemD system and service manager. While it has many uses, one of the key things you'll use it for is switching boot targets. With systemctl, you can move between different targets like graphical target or multi-user target, depending on what state you want your system in. Whether you're running a server, managing a workstation, or troubleshooting, knowing how to change these targets can be really helpful. Managing SystemD targets. Now let's see how we can manage targets using systemctl command. Viewing the current target. To see the current target your system is using, we can use systemctl get default. This command will display the default target that the system boots into. To list available targets, we can use systemctl list-unit-files-type target. This command will display a list of all targets along with their status. Alright, let's check out the configuration for graphical target. You can do this by running systemctl cat graphical.target. You can see the description of this target here, which, as you'd expect, it's a graphical interface. You'll also see what it depends on to run. In this case, it requires the multi-user target to be activated first. It also shows what targets and services need to run beforehand. To get the graphical interface working, it needs multi-user target, rescue target, and display manager service. We can also check out a multi-user target configuration file and see what it needs to run. To change the current target, we can use isolate command. For example, to switch between graphical target and multi-user target, you can use systemctl isolate multi-user. This command will immediately switch the system to a specified target, stopping services not needed by the new target and starting any new services required. And to set the default target, you can use systemctl set default multi-user. This command creates a symbolic ring from default target to a specified target. But how SystemD knows what to do and how to do things? We have something called unit. The concept of unit files replaces the sysv init scripts for services. What are SystemD unit files? Think of SystemD unit files like a remote control of your Linux system. These files are like TV remotes, but instead of controlling channels, they control services, devices, network resources, and even those rogue programs that won't stop running. With the command, you're in charge. In simple terms, units are like services or jobs in other systems, but they are way cooler. They can handle services, network connections, file system mounts, and even build you a resource pool. Okay, they won't actually build a pool, but they do a lot. Why break it down? In the world of SystemD, you can break down those complex, tangled messes you'd find in other init systems. Instead of one giant, all-in-one block, you get neat little units that are easier to manage and customize. It's like having separate buttons for turning on your TV, your speaker, and your popcorn maker. This organizes by function and allows you to easily enable, disable, or extend functionality without modifying the core behavior of a unit. Let's check out some of the features that make these units so darn useful. Socket-based activation. Sockets associated with a service are best broken out of the daemon itself in order to be handled separately. This provides a number of advantages, such as delaying the start of a service until the associated socket is first accessed. Think of this like that friend who only gets up when they hear the doorbell. Instead of launching services right away, SystemD can wait until the service is actually needed before waking it up. It's lazy, but it's efficient. Bus-based activation. Units can also be activated on the bus interface provided by dbus. A unit can be started when an associated bus is published. You know that moment when you get a ping on your messaging app and then you remember it exists? That's bus-based activation for units. Path-based activation. A unit can be started based on activity on or the availability of a certain file system path. This utilizes iNotify. It's like SystemD watch specific folders like a hawk and launch services when something new pops up. It's like having a guard dog for your file system, but with less barking. Device-based activation. Units can also be started at the first availability of an associated hardware by leveraging UDEV events. Got a new hardware? SystemD is on it. It will spring into action the moment your shiny new device connects. Implicit dependency mapping. Most of dependency tree for units can be built by SystemD itself. You can still add dependency or ordering information, but most of the heavy liftings is taken care of for you. SystemD will figure out most of the connections between units for you. It's like hiring a personal assistant who already knows how you like your coffee. Instances and templates. Template unit files can be used to create multiple instances of the same general unit. This allows for slight variation or sibling units that all provide the same general function. Need several versions of the same things? Templates have got you covered. Think of them like a cloning machine but for services. Easy security hardening. Units can be implemented some fairly good security features by adding simple directives. For example, you can specify no or read-only access to part of the file system, limit kernel capabilities, and assign private temp directory and network access. Want to lock things down? Just add a few simple settings and boom, more security. It's like installing a deadbolt on your door with a sticky note. Drop-ins and snippets. Units can be easily extended by providing snippets that will override part of the system's unit file. Instead of messing with the whole unit file, you can just add a little snippet to tweak things. It's like giving your code a haircut without chopping the whole thing off. Where are SystemD unit files found? The files that define how SystemD will handle a unit can be found in many different locations, each of which have different priorities and implications. The system's copy of unit files are generally kept in /lib systemd/system directory. This is where your system's default unit files hang out. It's like their VIP lounge, where they chill until called into action. When software gets installed, it usually drops its files here, ready to start and stop whenever you need. Managing units with systemctl. Okay, here's where the magic happens. systemctl is your command one for SystemD. You'll use it to start, stop, enable, disable, and check on units. Start and stop. To start a unit, you can use systemctl start unit name. And as you guess, systemctl stop unit name will stop it. And if you want a unit to join the boot up party, you can use systemctl enable unit name. Want to chill until you need it? Systemctl disable unit name will do the trick. Like a status update for your units, systemctl status unit name gives you the scoop. Reload and restart. Made some changes, use systemctl daemon reload to update the system's memory. To restart the unit, use systemctl restart unit name. And if you want to see what's going on, use systemctl list units. It's like a guest list for your system services. Shutting down the system, the old school way. Back in the day, shutting down a Linux system was like leaving a party. You couldn't just ghost, everyone needed a heads up. If you shut down without warning, you would risk losing all that unsaved work and maybe even corrupting files. And if your Linux server is a multi-user hangout spot, you've got to play nice and let folks know it's time to pack up. Shutdown commands, a gentle goodbye. To shut things down smoothly, use shutdown command. it sends a warning to everyone like a bartender yelling last call. Here's how it works. Sudo shutdown-h now will shut down your system ASAP. Sudo shutdown-r60 gives everyone a 1-minute breather before rebooting. And if you want to cancel it, use sudo shutdown-c. And here is some more options for shutdown command. -h halts the system. -r is for rebooting. And if you want to send a friendly note before it goes down, for example, if you want to tell everyone that in 15 minutes the system is going to shut down and they have to save their work, we can use sudo shutdown-h15, and in double quotation we send our message. System is taking a break in 15 minutes. Save your work. Reboot, halt, and power off. What's the difference? These commands are like the three amigos for shutting down. Halt stops everything but doesn't turn off the power. It's like taking a nap without turning off the lights. Power off halts and then cuts the power. And reboot stops the system and fires it back up again. Most of these commands are just shortcuts to systemctl, which means you can use whichever feels right, as long as it does the job. Advanced configuration and power interface. ACPI is like a yoga instructor for your computer, helping it manage energy efficiency. Before ACPI, BIOS handled power management, but it wasn't exactly eco-friendly. With ACPI, your system can take power naps. It's supported by Linux, Windows, and Mac OS. Everyone is in ACPI club now. There are some other ways that you can keep everyone in loop. There was a etc/issue and etc/issue.net displays a message before login, perfect for adding a warning. And we have etc/motd, message of the day. It's a perfect spot for putting important updates. And we have a message command. And the last command that I want to show you is message command, which controls whether a user can receive a message from the wall command. Users can run MESG --n to block incoming messages. However, it's important to note that shutdown messages sent by shutdown will still be delivered regardless of message setting. And that's it for this video. Hope you enjoyed it, and if you do, please subscribe and recommend it to your friends.